Section 4.4, Other Types of Equations. Our goals for this section are to solve radical equations algebraically and graphically, and then we're going to see how to solve equations that are reducible to a quadratic form, and see how to solve rational equations algebraically. Alright, so some general steps for solving radical equations algebraically. First step is to isolate a radical on one side of an equation, and then we will raise both sides of the equation to the power equivalent to the index on the radical. We'll then solve the resulting equation, and we want to check for extraneous solutions. We really need to check the solutions of the equation through substitution back into the original statement. Alright, so let's consider the square root of 3x plus 1 is equal to x minus 3. Alright, so to solve this equation, notice the first thing we wanted to do was to isolate a radical. Well, we have this radical by itself, and it is a square root. We hardly ever write that index of 2 on a square root, but I wrote it there on purpose to remind us. So what we do is we can square both sides of the equation. Now the square root of 3x plus 1 squared is 3x plus 1. X minus 3 squared is x squared minus 6x plus 9. So now we have a quadratic equation. Let's put it in standard form by subtracting 3x and 1. I'd have 0 is equal to x squared minus 9x plus 8. Now that factors as x minus 1 by x minus 8. So then setting each factor to 0, x minus 1 is 0, which means x is 1. X minus 8 is 0, which means x is 8. Now we have to check these. Let's check. X equals 1. The square root of 3 times 1 plus 1, is that equal to 1 minus 3? Now 3 times 1 is 3, plus 1 is 4. The square root of 4 is 2. 1 minus 3 is negative 2. That doesn't work. 2 is not equal to negative 2, so x is equal to 1 is not a solution. Let's check x equals 8. The square root of 3 times 8 plus 1, is that equal to 8 minus 3? 3 times 8 is 24. 24 plus 1 is 25. The square root of 25 is 5. 8 minus 3 is 5. That checks out. So there is only one solution to the equation, x equals 8. Alright, our second example. Negative 3x plus the square root of 11 plus 42x is equal to 4. The first thing that we'll do is get that radical isolated. I want to get this radical isolated, so I will add 3x to both sides. So then I have the square root of 11 plus 42x is equal to 3x plus 4. Squaring both sides. 11 plus 42x is 9x squared plus 24x plus 16. Let's put this in the standard form. I'll subtract the 11 and the 42x. Subtract the 11, subtract the 42x. And I have 0 is 9x squared minus 24 minus 42 is 18, minus 18x plus 5. Alright, now, is this going to factor? I'm not sure. Let's go to the quadratic formula. X is equal to 18 plus or minus the square root of, let's see, 18 squared is 324, minus 4 times 9 times 5 is 180. over 2 times 9 is 18. That's 18 plus or minus, let's see, 324 minus 180 is 144. Square root of 144 over 18. So that's x equals 18 plus or minus 12 over 18. Alright, so let's see, x equals, 18 minus 12 is 6. 6 over 18 is 1/3. 18 plus 12 is 30. 30 over 18. 30 over 18 is 5/3. Alright, so let's check these. Alright, if we check x is 1/3, let's see, negative 3 times 1/3 plus the square root of 11 plus 42 times negative 1/3. And is that equal to 4? So that's negative 1 plus the square root of 11. Now 42 times negative 1/3, that would be 11 minus 14. 42 times 1/3 is 14. So that's negative 1 plus the square root of negative 3 is equal to 4. That's not equal to 4. Alright, so that one doesn't work. Alright, so x is not equal to 1/3. Alright, let's check the other solution. X equals 5/3 would give me negative 3 times 5/3 plus the square root of 11 plus 42 times 5/3. Is this equal to 4? So that would give me, what, negative 5 plus, let's see, the square root of 11 plus, what's 14 times 5 is 70. So negative 5 plus the square root of 81, that's negative 5 plus 9, which is 40. That checks out, and so x equals 5/3 is the solution of the equation. So I'm looking back real quick, and I noticed I made an error, a substitution error. Up here in the check for 1/3, I substituted a negative 1/3. So let's do this check again. So we had negative 3 times 1/3 plus the square root of 11 plus 42 times 1/3. That's the correct substitution. And so that would give me negative 1 plus the square root of 11 plus 4. So that's negative 1 plus the square root of, 11 plus 14. 11 plus 14 is 25. And that's negative 1 plus 5, which is 4. And that does check. So x equals 1/3 is a solution of the equation. So they both work, and this equation does have two solutions. Solve the equation x plus 20 to the 2/3 power minus 16 is equal to 0. I'd say, well, this isn't a radical equation. I don't see any radicals. But remember, maybe from intermediate algebra course, that in general, if you have a to the m over nth power, that can be written as the nth root of a to the m. So if I rewrite this, then I have x plus 20 to the 2/3 power. That's the same as the cube root of x plus 20 squared minus 16 is 0. And this is a radical equation. So let's isolate the radical. I'll add 16 to both sides. So then the cube root of x plus 20 squared is equal to 16. Now, let's remove the radical. I will raise both sides to the third power. So then x plus 20 square is equal to 16 to the third power is 4096. Now I can apply the square root property. So then x plus 20 is the positive or negative square root of 4096. The square root of 4096 is 64. So x plus 20 is positive or negative 64. So then x would equal negative 20 plus or minus 64. So negative 20 minus 64, that's negative 84. Negative 20 plus 64 is positive 44. All right, let's check these. I'm going to use the calculator here to help me with the arithmetic. So substituting the negative 84, quantity, negative 84 plus 20, raise that, and now I need 2/3 in quantity, so I have to type it in like this, quantity 2/3. And that's 16 minus 16 is 0. That checks out. Let's check the 44. 44 plus 20, raise that to the 2/3 power. And that's also 16. Subtract 16 is again 0. So both of these checked out. All right, let's look at this one. We have the square root of x plus 1 subtract the square root of 2x minus 5 is equal to 1. All right, so the first thing we want to do is isolate one of the radicals. So what I'm going to do is I'm going to add the square root of 2x minus 5 to both sides. All right, so then I have the square root of x plus 1 is equal to 1 plus the square root of 2x minus 5. Now, I'm going to square both sides. We have to be careful here. Remember that when you have a plus b square, that's a square plus 2ab plus b square. And in particular, that's what we have on the right-hand side. We have 1 plus the square root of 2x minus 5 squared. All right, so let's be careful here. The left-hand side's easy. The square root of x plus 1 is just square root of x plus 1 squared is just x plus 1. Now on the right-hand side, I would have 1 square plus 2 times 1 times the square root of 2x minus 5 plus the square root of 2x minus 5 squared. So then x plus 1 is 1 plus 2 times the square root of 2x minus 5 plus 2x minus 5. Let's clean up that right-hand side. X plus 1 is equal to 2x minus 4 plus 2 times the square root of 2x minus 5. All right, now what I'm going to do is, again, see now I have this equation, but it still has a radical in it. So I've got to isolate that radical again. Let me isolate that square root of 2x minus 5. I'll subtract 2x from both sides. I will add 4 to both sides. So now I have negative x plus 5 is equal to 2 times the square root of 2x minus 5. Now, thinking ahead a little bit, I know I'm going to need to square both sides at some point. I can divide by 2 if I want here, but then I would have a fraction that I'm going to have to square. There's nothing really wrong with that. I can do it, but I'd rather not. So instead what I'm going to do is square both sides at this point. Now, we have to be careful here because now I have a times b squared on the right-hand side, which remember is a squared b squared. All right, so left-hand side would be negative x, no, it wouldn't be. because negative x plus 5 times negative x plus 5 times negative x plus 5, well, that would give me a positive x squared, a minus 10x, and a plus 25. The right-hand side would then give me 2 squared is 4, and 2x minus, the square root of 2x minus 5 squared is 2x minus 5. Simplifying the right-hand side gives x squared minus 10x plus 25 is equal to 8x minus 20. And so now I see this is quadratic. Let's get it to a standard form. I'll subtract 8x from both sides, and I'll add 20 to both sides. So then x squared minus 18x plus 45 is equal to 0. Now, I see that this factors as x minus 3 by x minus 15. And so my solutions, I hope, are 3 and 15. But let's make sure and check our work here. Alright, so checking x equals 3. The square root of 3 plus 1, subtract the square root of 2 times 3 minus 5, is this equal to 1? So that's the square root of 4, which is 2, minus the square root of 6 minus 5 is 1. The square root of 1 is 1. That checks out. X equals 3 works. Let's check x equals 15. The square root of 15 plus 1, subtract the square root of 2 times 15 minus 5. Is this equal to 1? 15 plus 1 is 16. The square root of 16 is 4. 2 times 15 is 30. 30 minus 5 is 25. The square root of 25 is 5. And 4 minus 5 is not equal to 1. So we throw away the 15 and only accept x equals 3. Alright, we're asked to now solve graphically using a calculator, and we have the square root of r squared plus 3r minus 1 is equal to 4 plus the square root of 5r minus 1. And actually, I don't know that we could solve this without a calculator because we'd have to square both sides twice, and I think we would get some higher powers of r than just the second power. So we'll use a calculator. There's a couple of different approaches to this, but what I'm going to do is I'm going to graph the left-hand side as my y1, and the right-hand side as my y2, and I'm going to find points of intersection. So find points of intersection. And so then the solutions are the x-coordinates of the points of intersection. Alright, so let's try this out. Y equals screen, let me clear that out. My y1 is the square root, now I'm not going to use r, I'm going to use x. X squared plus 3x minus 1, close off that radical. Alright, and y2 is 4 plus the square root of 5x minus 1. Now, just to distinguish the two graphs, I'm going to graph the y2 as a thicker line by moving all the way to the left and hitting enter a single time. I'll get a thicker graph just to help distinguish the two graphs. Alright, my window, let me change back to the standard window by hitting zoom 6, and that'll start graphing it. Alright, so I see this graph, and it looks like there might be an intersection over to the right. So let me adjust my window so that I can see a little bit more to the right. So let me go from -10 to 15 on the x, and while I'm at it, let me adjust the y maximum to 15 as well, and regraph. Alright, and I see a point of intersection right here. Let me calculate it. Alright, and so it looks like we have the one intersection and 9.45 comma 10.80. So my solution then is R equals approximately 9.45. And that appears to be the only solution of this equation. So now let's see how to solve equations that are reducible to a quadratic form. In these equations, we're going to use an appropriate substitution to write the equation in a quadratic form. We'll solve the resulting quadratic equation, and then we have to reverse the substitution and solve the equation in terms of the original variable. Let's see an example. Here we're asked to solve the equation 9y to the fourth plus 12y squared minus 5 is equal to 0. So this is not quadratic because notice we have this y to the fourth term. So it's not quadratic. But if we make a substitution, if I make the substitution, if I let u equal y squared, then notice that u squared would be y squared squared, which is y to the fourth. And so using this substitution, I can rewrite the equation as 9u squared plus 12u minus 5 is equal to 0. And so that original equation is now reduced to a quadratic form in u. So now we're going to solve this resulting quadratic equation. And we have a number of choices here on how to solve this equation. I'm just going to use the quadratic formula. So then u would equal negative 12 plus or minus the square root of 12 squared is 144 minus 4ac, 4 times 9 times negative 5, that would be minus negative 180. 4 times 5 is 20, times 9 is 180, over 2a, 2 times 9 is 18. So then u would equal negative 12 plus or minus the square root of 144 plus 180 is 324 over 18. Now the square root of 324 is 18, so we have u is equal to negative 12 plus or minus 18 over 18. Alright, so we do get rational solutions to that equation. And so then reducing, let's see, negative 12 plus 18, that's 6. 6 over 18 is 1/3. So I find that u is equal to 1/3, or negative 12 minus 18 is negative 30. Negative 30 over 18, let's see, 30 over 18, reduce that by a factor of 6, gives us, what, 5/3. U equals negative 5/3. Okay, but we didn't want to solve for u. Our original equation was in terms of y. So we now make that substitution back and recall that if u is equal to y squared, then now let me change colors here. And so now y squared is equal to 1/3, or y squared is equal to negative 5/3. And we can solve these resulting equations. So then y would equal the positive or negative square root of 1/3, or y would equal the positive or negative square root of negative 5/3. So we get two solutions here for the first statement. Y is equal to positive or negative square root of 1/3. But now, if we look at that second statement, we have a square root of a negative 5/3. And that would give us complex or imaginary solutions. So we would write our solutions as y equals positive or negative 1/3, square root of 1/3, excuse me, and y equals positive or negative root 5/3, and then we have to have that I. So there are 4 solutions to this equation. 2 of them are real, and 2 of them are imaginary. See another example. X to the 2/3 plus 27x to the 1/3 is equal to negative 50. So the first thing I'm going to do is I'm going to write this in a more standard form by adding 50 to both sides. So we have x to the 2/3 plus 27x to the 1/3 plus 50 is 0. Now, I'm going to make a substitution. Notice this sort of looks quadratic, except it's got those fractional exponents instead of being nice rational numbers. So if I make this substitution, u equals x to the 1/3, then notice that u square would be x to the 1/3 square, and power to a power, multiplying the exponents, that's x to the 2/3. And so if I make the substitution u equals x to the 1/3, then I can rewrite the equation as u square plus 27u plus 50 is 0. And I'm going to solve this one. I think this factors fairly easily as u plus 2 by u plus 25 is 0. And so then u plus 2 is 0, which implies that u is negative 2. And u plus 25 is 0, which implies that u equals negative 25. Okay, but this is in terms of u. Our original equation was in terms of x. So let's make the substitution back. Remember that u was x to the 1/3. So then x to the 1/3 is negative 2. And x to the 1/3 is equal to negative 25. And now we need to solve each of those equations for x. Well, they both involve a 1/3 power, so what I'm going to do is I'm going to raise both sides of each of these equations to the 3rd power. Yielding x equals negative 8, and x equals negative 25. Let's see, 25 to the 3rd power is 15,625, so x would equal negative 15,625. Here's a third example. X to the negative 2nd plus 5x to the negative 1st is 24. I'll again put this in a more standard form by first subtracting 24 from both sides. So then we have x to the negative 2nd plus 5x to the negative 1st minus 24 is 0. And I'll make the substitution u equals x to the negative 1st. In making that substitution, now notice that u square would be x to the negative 1st squared, which is x to the negative 2nd. Resulting in the equation, u square plus 5u plus 24 is 0. Sorry, that should be a minus 24. Solving this equation, again, this looks like it'll factor easily. Multiplying to 24 and adding to 5 is 8 and 3. So then u plus 8 by u minus 3 is 0. So u plus 8 is 0, which implies that u is negative 8. U minus 3 is 0, which implies that u equals 3. So we have 2 solutions in terms of u, but again, we want the solutions in terms of x. So let's substitute back. If u is negative 8, that means that x to the negative 1st is negative 8. If u equals 3, that means x to the negative 1st is 3. Recall that x to the negative 1st power is the same as 1 over x, so 1 over x equals negative 8, and 1 over x equals 3. And solving this for x, this says the reciprocal of x is negative 8, then x is negative 1/8, the reciprocal of negative 8. And x is equal to 1/3, the reciprocal of 3. All right, now let's see how to solve rational equations. So rational equations are equations that involve algebraic fractions. All right, so they're fractions that have variables in the numerator and or denominator, basically. I should say polynomials in either the numerator or denominator. And a technique for solving these equations is to first clear the equation of fractions by multiplying both sides of the equation by the least common denominator, the LCD for the equation. And that'll give us a polynomial equation that we'll solve, and then we're going to check the solutions in the original equation just to be sure. Alright, so here I've got the equation 10 over x plus 2 over x plus 3 is equal to 9 over 4. So I notice that I've got three factors in the denominator. I have a factor of x, I have a factor of x plus 3, and I have a factor of 4. And none of them have any common factors. So then my LCD for this equation is x times x plus 3 times 4. So if I multiply through both sides of the equation by that least common denominator, I would have x by x plus 3 by 4 times 10 over x plus x by x plus 3 by 4 times 2 over x plus 3 equals x by x plus 3 by 4 times 9 over 4. Now, some nice things happen here. If I multiply through everything on the first term, that factor of x reduces out. In the second term, the factor of x plus 3 reduces out, and in the third term, or on the right-hand side, the factor of 4 reduces out, leaving x plus 3 times 4 times 10 plus x times 4 times 2 equals x times x plus 3 times 9, which is now a polynomial equation. And we'll solve this equation. Alright, so notice that on the first term, 4 times 10 is 40. And distributing through the x plus 3, that's 40x plus 120. X times 4 times 2 is 8x. And on the right-hand side, let's see, x times x plus 3 is x squared plus 3x times 9. 9x squared plus 27x. So notice that this is a quadratic equation. So I have 48x plus 120 is equal to 9x squared plus 27x. I'll move everything to the right-hand side. 0 is 9x squared minus 21x plus 120. Now I think this will factor, but I'm not sure. I'm just going to go to the quadratic formula. So x would equal 21 plus or minus the square root of, let's see, negative 21 squared is, 21 squared is 441 minus 4 times 9 times 120 4,320. Oh, that should be a negative 120. Sorry about that. So I made an error there when I subtracted. This should have been a negative 120. So 4AC would then give me a plus 4,320 over 2A over 18. Now 441 plus 4,320 is 4,761. So then x is 21 plus or minus the square root of 4,761 over 18. And the square root of 4,761 is 69. So x is equal to 21 plus or minus 69 over 18. Alright, and so now we're getting the two solutions out of this. Let's see, we have 21 minus 69 over 18 is negative 8/3. And let's see, 21 plus 69 over 18 is 5. Now I'm going to check these solutions in the original equation. And one thing that I would really be concerned about is if I have a division by 0. So notice in this first fraction x, we wouldn't want x to be 0. In the second fraction, 2 over x plus 3, we wouldn't want x to be negative 3. Now we don't have either of those, so I'm fairly confident in my solutions, but let's check to be sure. I'll use the calculator. So let's see, 10 over the first x value is negative 8/3 plus 2 over, let's see, I need negative 8/3 plus 3. I'll close that off and hit enter. 2.25 is 9/4. So that's good. And let's check the other solution. Let's see, 10 over 5 plus 2 over, I missed the 2, 2 over quantity 5 plus 3 is 2.25 as well. I'm very confident in these solutions to the equation. Let's see another example. Negative 2 over x plus 61 over x squared minus 5x is equal to negative 6 over x minus 5. So again, I want to multiply through by the least common denominator. But look at that second denominator. X squared minus 5x. Notice that that can be factored as x times x minus 5. So if I look at the denominators, I have an x, I have, an x and an x minus 5, and in the third I have an x minus 5. So I don't need to have any repeats of factors unless we actually have like a factor being squared. So the LCD in this case is x times x minus 5. Alright, so I'd have x by x minus 5 multiplying through times negative 2 over x plus x by x minus 5 times 61 over x by x minus 5, I'm thinking of the factored form there, equals x by x minus 5 times negative 6 over x minus 5. Now again, nice things happen here. In the first term, the x's are removed. In the second term, the x and the x minus 5 is removed. And on the right-hand side, just the x minus 5 is removed, leaving x minus 5 times negative 2 plus 61 equals x times negative 6. So I have what? Negative 2x plus 10 plus 61 is negative 6x. This is a linear equation. Negative 2x is plus 71 is negative 6x. Add 2x to both sides. 71 is negative 4x. And dividing through by negative 4, x is negative 71/4. Alright, let me check this in the calculator. Let me move that over here so I can see the whole equation better. All right. Negative 2 over my x value is negative 71 fourths plus 61 over quantity. Let's see, I need negative, so I open another parenthesis there, negative 71 fourths. I need to square that, minus 5 by negative 71 fourths. Close the negative 71 fourths, close the denominator. Equals, all right, so that's the left-hand side. I get that result. Now, negative 6 over x minus 5. Negative 71 fourths, subtract 5. Close off that denominator, and I got the same result on both sides. So I'm confident in my solution, negative 71 fourths. All right, let's see one more example. We have 3x minus 2 over 3 plus 9x over x plus 1 equals x. All right, so again, if we're going to use this technique where we multiply through by the LCD, we have to determine what is the LCD. So let's see, I have a factor of 3 in the first denominator. I have a factor of x plus 1 in the second denominator. And on the right-hand side, that x is an x over 1. So the factor there is a 1. And multiplying by 1 is boring. I'm not going to include it. The LCD is 3 by x plus 1. All right, so let me multiply through both sides of the equation by 3 times x plus 1. So I'd have 3 times x plus 1 times something plus 3 times x plus 1 times something equals 3 times x plus 1. All right, let's fill in the other terms. 3x minus 2 over 3 plus 3 times x plus 1 times 9x over x plus 1 equals 3 times x plus 1 times x. All right, some nice things happen here. In the first term, the factors of 3 are removed. In the second term, the factors of x plus 1 are removed. On the right-hand side, nothing's removed. Yielding x plus 1 times 3x minus 2 plus 3 times 9x. Right-hand side, I've got 3 times x plus 1 times x. All right, x plus 1 times 3x minus 2. Multiplying those binomials, distribute, combine like terms, FOIL, however you want to think of it. We'd have a 3x squared plus x minus 2. 3 times 9x is a 27x. On the right-hand side, 3 times x plus 1 is 3x plus 3. Times x is 3x squared plus 3x. Simplifying, I'd have 3x squared plus 28x minus 2 is 3x squared plus 3x. Notice that those 3x squares, if I subtract one, those terms are going to go away. If I subtract 3x squared from both sides, those terms go away, leaving a linear equation in x. 28x minus 2 is 3x. I'll move the 28x to the right through subtraction. Negative 2 is equal to negative 25x. And let's see, dividing by negative 25, x would equal positive 2 25ths. And again, only one solution here. All right, so let's check that solution on the calculator. All right, so let's see, 3x minus 2 over 3. So open quantity, 3, another quantity, times 2 25ths minus 2, and now I've got to divide that by 3. To that, I need to add open quantity for the numerator, 9, open quantity for the substitution, 2 25ths. Close the numerator, divide that by open quantity, 2 25ths plus 1. And this better come back as 2/25ths. 0.08, I'm pretty sure that's 2/25ths. It is. So I'm confident in my solution to the equation. Now here we're asked to solve for x, but we're given a literal equation. Instead of having more numbers, I have other variables. I have a formula. We're told that x times y over x minus z is equal to w. Whatever those variables mean, that's not important right now. What is important is we're asked to solve for x. Well, this equation has a rational form, so I'm going to use a similar technique first. I'm going to multiply through by the LCD. Well, in this case, there's really only one denominator. There's only one fraction. So the LCD is just x minus z. So I'll multiply through both sides by x minus z. Now on the left-hand side, those factors of x minus z go away, leaving xy on the left. And on the right, I'll apply the distributive property. I'd have wx minus wz. Now I'm asked to solve for x, and what I see is that there are two terms that have x in it. I want to get both of those terms with x on one side. So what I'll do here is I'll subtract wx from both sides, yielding xy minus wx is equal to negative wz. Now I'm going to use factoring. Notice that x is a common factor for both of those terms on the left-hand side. So that means I can write the left-hand side as x times y minus w. And that's equal to negative wz. So now I can isolate the x through appropriate division. I will divide both sides of the equation by y minus w, yielding x is equal to negative wz over y minus w. Now, this is acceptable, but sometimes we would see it a little differently, if we had the answer key. And one way to do this is, maybe we don't want that negative. Maybe we don't like that negative in the numerator. And so what we do, maybe, is multiply both numerator and denominator times negative 1. So if I multiply times negative 1 times negative 1, I get an alternative form. And I'll move this up. So, or, multiplying through by the negative 1, I would have x is equal to negative wz times negative 1 is wz, and y minus w times negative 1. So notice that negative 1 times the negative w would give me a positive w, and the negative 1 times the y would give me a minus y. And this is also an acceptable form. Alright, let's see another example. We're asked to solve for x, and we have 2y plus 3 over 4 plus 3x minus 1 over x plus 5 is equal to y. And again, we're asked to solve for x. Alright, so as I did before, I'm going to first multiply through by a common denominator. And in this case, the LCD is 4 by x plus 5. Alright, so going through the distribution and careful removal of factors, I would have x plus 5 times 2y plus 3 plus 4 times 3x minus 1 is equal to 4 by x plus 5 by y. Alright, so now I'm going to simplify everything here. Let's see, I'd have a 2xy plus a 3x plus a 10y plus a 15 plus a 12x minus 4. On the right-hand side, I'd have a 4xy plus a 20y. Now, I was asked to solve for x, so I'm going to get everything with the x on one side and everything without the x on the other side. So let's see. I need to let me move everything. I'm going to move everything. I want everything with the x on the left. So let me subtract a 4xy. Oh, there's a like term for that. I'll subtract the 4xy here. All right, and everything that doesn't have an x, I'm going to move to the right. So let's see. I'm going to subtract this 10y. Oh, it has a like term over here. And I'm going to subtract 15. And I'm going to add 4. Yielding. Let's see, 2xy minus 4xy. That's a negative 2xy. I have a plus 3x and a plus 12x. That's all that remains on the left. On the right-hand side, I'd have a 0xy. I'd have a 10y, a minus 5, and a plus 4. A minus 15 and a plus 4. All right, let me simplify things. Negative 2xy plus 15x equals 10y minus 11. Now, like I did in the previous exercise, I can factor out the x. So I'd have x times negative 2y plus 15 equals 10y minus 11. And now I can solve for x by dividing through by the negative 2y plus 15. And so then this tells me that x is 10y minus 11 over negative 2y plus 15. I'm just going to leave it like that. We're going to use these sort of techniques in a later chapter when we find what's called the inverse of a function. And so I'll actually be doing that in chapter 5. All right, that concludes the presentation for this section.